Do you get nervous before interviews? That sinking feeling when you wonder, what are they going to ask me this time? Especially for a highly technical role like piping engineering. Well, worry no more. In this video, we are giving you the complete blueprint to crack your next piping engineering interview. We are breaking down exactly what to say, from the initial "tell me about yourself" to the final "do you have any questions for me?" You'll get a full mock interview simulation, common questions, and winning answers that will set you apart. Welcome back to the Differential Science channel. I'm your career coach, and today we are tackling the piping engineer interview. This is a critical role that demands both deep technical knowledge and strong project management skills. We are covering the most frequently asked questions, spanning introduction, technical, role-specific, behavioral, and closing rounds. Consider this a realistic simulation, a clone of the actual interview process you'll face. Stick around, because this guide will turn your nervousness into confidence. Let's get started. Round 1. Introduction and Icebreaker. Welcome. Thank you for coming in. To start, please walk me through your resume and tell me a bit about yourself. Thank you. I'm a piping engineer with 5 years of experience, currently at Expertise Company, where my focus is on detailed design and stress analysis for petrochemical facilities. A key achievement was leading the 3D modeling and stress validation for a $50 million expansion project, which reduced potential pipe failures by 15% based on our last internal review. My core strengths lie in CSER 2, ASME 31.3 compliance, and optimizing material selection for harsh environments. I'm eager to bring this expertise to a company like yours that is pushing boundaries in building process plants and contribute to your large-scale projects. Round 2. Technical role-specific questions. Let's get into the technical details. First, can you explain the main difference between pipe schedule and pipe nominal size? Certainly. The nominal pipe size, NPS, is a dimensionless designator that relates to the approximate diameter. For instance, NPS 6 refers to a pipe with a roughly 6-inch diameter. The pipe schedule, SCH, however, relates to the wall thickness of the pipe. A higher schedule number, example SCH 80 versus SCH 40, means a thicker pipe wall for a given NPS, which is necessary to withstand higher pressure or external loads. Both are critical for material selection and design pressure calculations. Good. Second, what is a pipe rack, and what are the key considerations when designing one? A pipe rack is the main elevated support structure, usually steel or concrete, that carries process pipes, utility pipes, power cables, and instrument cables between equipment and units in a plant. Key design considerations include thermal expansion, contraction of the pipes, maintaining adequate spacing for access and maintenance, like flange bolting, providing sufficient flexibility for stress minimization, ensuring proper drainage on the rack, and adhering to fireproofing and load distribution standards dictated by the applicable codes and standards. How do you define pipe flexibility, and what is its primary purpose in design? Pipe flexibility refers to the system's ability to absorb movements, typically from thermal expansion contraction, without overstressing the pipe material, fittings, or connected equipment like pumps and vessels. Its primary purpose is to minimize reactive forces and moments by using loops, bends, expansion joints, or specific pipe routing to ensure the structural integrity and safety of the entire system throughout its operating life cycle. Finally, when would you use a spectacle blind versus a figure-8 blind, and what is their function? Both are used for positive isolation to prevent fluid flow, crucial for maintenance or safety. A spectacle blind is essentially a figure-8 shape, with one solid end and one open ring end, permanently installed in the line. You can simply rotate it to either blind the line or open it. A figure-8 blind is actually the same device, but sometimes the term is used interchangeably or to refer to the specific shape. They are mandatory for critical isolation points to visually confirm the line is safe to work on. Round 3. Behavioral questions. STAR method. Tell me about a time you had to handle a significant conflict between the piping team and the structural team regarding a clash in the 3D model. That happens frequently on large projects. On my previous project, we were running into repeated clashes in the pipe rack area. The structural team had placed a major beam where my large bore line was planned, threatening our schedule. My task was to mediate a solution that maintained the structural integrity while minimizing the piping route modification, which would have required a time-consuming stress reanalysis. I first convened a joint 3D model review meeting with both lead engineers. I presented the pipe stress report data, showing why our route was critical for flexibility. I then proposed 3 alternative solutions, focusing on a minor vertical shift of the structural beam, which was feasible for their team. They agreed to the vertical shift, which we executed immediately. This compromise saved us over 40 man-hours of rework in the piping team and allowed us to keep the project on its original fabrication schedule. Round 4. HR and closing questions. Okay, we're nearing the end. What are your salary expectations for this piping engineer role? Based on my 5 years of specialized experience in high-pressure systems, my research on industry standards for this region, and the scope of responsibility outlined, my expectations are within the range of $85,000 to $95,000 annually. However, I'm open to negotiation based on the total compensation package, including benefits and bonuses. Finally, do you have any questions for me? Yes, I do. My first question is, what is the most significant technical challenge the piping team is currently focused on solving, and how would this role contribute to that solution? My second question is, could you describe the typical collaboration structure between the piping team and the project management team on a new EPC venture? That was a highly realistic simulation. Now, let's distill the golden rules that the candidate nailed. Rule number 1. The power of specificity. Notice how the candidate didn't just say they had experience. They quantified it with metrics like $50 million project and 15% reduction in failures. Always quantify your achievements. Rule number 2. Code language. For technical roles like piping, you must speak the language of codes. ASME B31.3, B31.1, API 570. Mentioning them shows you're not just a designer, but a safe and compliant engineer. Now for the pro tips that separate the hired from the rest. Body language. Maintain strong eye contact and an open posture. Even on a video call, sit upright and nod to show engagement. A confident tone is half the battle. The power of research. The candidate knew to ask about the company's new EPC venture. Always thoroughly research the company, its latest projects, and its culture. Tailor your answers to fit their mission. The art of asking questions. Having insightful questions is non-negotiable. It shows you're interviewing them as well, and you're thinking beyond the CD screen. The follow-up. Always send a personalized, professional thank you email within 24 hours of the interview. Reiterate your interest and briefly mention one key point you discussed. If you found this complete guide to crushing your piping engineer interview helpful, please give it a thumbs up sign and share it with a friend who's also job hunting. Subscribe to the channel for more career building content like this. Let me know in the comments below, which field are you preparing your interview for right now? Your input helps us decide what content to make next. Up next, we'll be tackling top 5 software tools every piping engineer must master. Stay tuned and keep building that amazing career.